Hello everyone, welcome back to SAT Math Question of the Day. Here's our question of the day. Please try it out, pause the video, and then we will go over it. Okay, in order to keep a manufacturing satellite from falling to the Earth, malfunctioning satellite from falling to the Earth, space agency officials decided to use a powerful rocket. At the time the rocket is attached, the satellite will be traveling with an initial velocity v0, and for every second that the rocket fires, it will add approximately 180 meters per second to this velocity. Okay. Yeah. Seth was a physics major and undergraduate. In order to ensure safety on Earth, the velocity must be increased to at least 3,800 meters a second. Also, the rocket can fire for no more than 4 seconds. Okay. For the initial velocity of the satellite v0, which of the following systems of inequalities best models the situation where time is in seconds? Well, for no more than, so this doesn't make sense. What we need to do is we need to figure out which system of inequalities models the situation. So t is less than 4, isn't it? T is less than or equal to 4.
Condition... the also condition, the rocket can fire for no more than 4 seconds. That is simply, T is the number of seconds for firing the rocket.
Right.
That condition is simply T is less than or equal to 4.
Right, so we can immediately eliminate these. Good idea to start eliminating choices.
Yeah. Are there only 4 choices?
Yeah, there are only 4 choices, yeah.
Okay, good.
Yeah. Now, it seems like this would be the right answer, because you want the velocity to be at least 3,800, but this is a physics question. The initial velocity plus the 180 meters per second, so this is 180 meters per second, multiplied by seconds.
By per second.
What? 180, right, we'll add approximately 100 meters per second, right. Per second, right.
If for every second the rocket fires, the increase in velocity is 180 meters per second.
Exactly.
So indeed, 180 is the acceleration.
Absolutely right. Right.
Those meters per second squared.
That's right. Meters per second.
Yes.
Per second, but the seconds cancel, so this unit becomes 180. Well, the unit here then becomes meters per second, which is what you want because the units are 3,800 meters per second. So here all the units make sense. Here, none of the units make sense.
No.
Yeah. Yeah.
Well, the units of C do make sense, but the units of C's first inequality, all 3 terms have the same units.
Right.
But the statement is is different from what the condition of the problem is.
Right. Right. So then after eliminating,
so obviously, it turns out following your nose works.
So after eliminating
the first choice. Actually, first choice is simply a reading of the data in the problem.
Right. And it's a really, if you think about it, this is in at least 3,800. And this is a no more than 4 seconds. This is the only one that has a less than 34 and a greater than 3,800. Not the best way to do the problem, but it certainly works. But this question does, if you want to fully understand it, it requires some knowledge of physics, doesn't it? It's a little bit.
If you know, no, I don't know about that, but it's easier if you have some knowledge of physics.
Yeah, it's easier if you have some knowledge of physics, right? Unfortunately,
but then the concepts of rate are taught, but what's not emphasized in math, but is emphasized in physics, is the rate of a rate.
Right. Yeah.
Right.
Right. The rate of change of a rate. The rate of
But
change of a rate.
This concept of rate can apply to anything. It can apply to a rate.
Right. Right. Each second,
Yeah.
the rate, each second, the speed goes up.
Yeah.
100
Each second, yes. So we're talking about the rate of increase of a speed.
Exactly. And
So
that
if
is
you could think of a speed as a kind of quantity all by itself, we're interested in rates involving speeds.
Right.
But in physics, they emphasize that speed is itself a rate.
Right.
Okay. All right, good.
So known as acceleration.
So should we ask if it makes any sense at all to use a calculator in this problem?
Yes. And by the way, that's a lead into I checked on Blue Book. You do get the full Desmos calculator on the SAT, so we can start using that. Yes, does it make sense? No, it seems like a calculator is completely useless on this problem because you have to write the equations. You don't have to solve anything. So
right.
There
is no numerical calculation. All of the numbers in all of the choices come from just the numbers that are given in the problem.
Right. Yeah. So there's no need for a. Oh, sorry. There is no need at all to.
I wouldn't say it's no need. I think I would say unnecessary. It is. It just doesn't make sense to use a calculator.
Right. Yeah. I mean, it doesn't help you.
That's
yeah. Okay. So the answer would be A. So let's see how they do it. Okay. A. Okay. Good. Nice work.
They agree with us.
How they do it. Step-by-step solution. Only 4 steps. Okay. To write an expression for the total velocity. Now that sort of requires a little bit of knowledge of physics, but no. Yeah, not really. I mean, yes, yeah. That does require knowledge.
Do they say velocity instead of speed?
Yeah. What is this? Oh, that's weird. Okay, so you move that around a little. Okay. Also, the speed must be at least 3,800. Okay. Initial velocity plus rocket's contribution is total velocity. So,
let me see. Do they use the word speed or velocity in this problem? I forgot.
Yeah. Oh, you mean in the initial problem?
Yeah.
Probably velocity.
Well, let's see.
Yeah, velocity. Yeah, everything is velocity. Yeah. Now, the answer, they're being a little sloppy because the answer is changing to speed.
Total speed. So one element of information is the similarity between velocity and speed.
Yeah.
Oh, there's where we get they skirted over a usage of words in physics.
Yes.
In physics, velocity also specifies the direction of motion.
Yes.
Whereas speed means the magnitude of motion independent of the direction. And in fact, in physics, if the thrust of the rocket is not parallel to the direction the thing is moving, then the velocity will change, but the speed will not change the amount that the speed would change if the thrust were in the direction of the motion.
So what they're doing is
So the idea is that so rockets, they use corrections of rockets to change the direction of the motion of the satellite and not just the speed.
right.
Right. But this issue in physics is skirted.
Yeah. Because this test doesn't deal with that issue. So this assumes motion in one direction. In other words, the thing goes this way. You push it more, it goes this way.
Yeah.
Notice everything is straight, one direction. There's no change in direction. So therefore, all of these assumptions or the stuff about speed and velocity is really sloppy. Because if it's in one direction, the speed is equal to the velocity. Assuming it continues to go in one direction, doesn't reverse. Yeah, okay. So I think
it's not just reverse. No, it's changing the angle, motion.
No, if it reverses, the velocity.
So the worst case is that if a satellite is moving in a certain direction, and the thrust is perpendicular to its direction of motion, then the speed doesn't change at all. While the thrust is being applied, the rocket's motion becomes circular.
Mm.
So the speed going around the circle is unchanged, but the direction of heading changes steadily.
Right.
Yeah.
Okay.
Then of course, what this completely ignores is the issue of how the velocity varies because of gravity. The whole point of an orbiting satellite is that its path is not a straight line.
Okay, stop. We're not. Yeah. The other thing
this is utterly deficient as a physics problem.
Okay, we know you're okay, but the other thing that they've ignored is if you don't really know, it's possible that there are people who are not really knowledgeable about this equation. You don't really need it. You don't really need it, do you? Because you can just sort of look at it and just take a chance with the answer. They're telling you that something has to be at least 3,800 and less than 4. The only choice is this is the only choice that has a greater than 3,800. So you don't even have to know any physics. You could just take a chance on this question,
The other one, so choice C, you eliminate the 180T is less than 4 choices.
Right.
And let's see choice C again.
Those are the choices.
So in choice C is equivalent to 3,800. I'll put this way. This is equivalent to 3,800 is less than. No, I'm sorry. No, it's a similar thing. In choice A, it says something is greater than 3,800. Here, something is greater than 3,800, and the something is 180T minus V0.
Choice A. That's
but obviously, it's simply by, so you can't distinguish between choice A by the sign of the 3,800 and the inequality, but you can distinguish with them because choice A reads off, it codes what the problem says.
Yeah,
choice C does not.
Yeah, choice A is the only one that makes any sense at all, just by looking at something had to be greater than 3,800.
Well, sense in this sense means consistency with what the problem says.
Right. It's worth taking.
Though there are other problems for which choice C will make sense.
Of
Whether it
Yes.
makes sense doesn't make sense without specifying what the problem is.
Fine, fine. It makes sense in the context of this problem.
Yes,
With
yes, yes.
but come on. Obviously, it's in the context of this problem. We don't really have to write this. We're just wasting everyone's time.
Well,
Right?
it's simply approach SAT. Read, we say we harp on this lots. Read the problem.
Yeah, I know. That was a mistake I made yesterday. Right. Okay, but but even if you don't know any physics at all, you don't even understand that question about the velocity, the initial plus the increase in velocity is the final velocity. Still, you don't really even need it. It's the only question that makes sense. The only answer that makes sense. Just take a chance on it. Okay, I think we're done. Seth is now clearly showing his background as a physics major at Cooper Union years ago, but he now
Decades ago.
but he now holds a PhD from math at
Less than a
MIT.
century ago. Well, more than half a century ago.
And he's been a professor emeritus at University of Albany for a while. He's been retired for a few years. I'm Joel. I'm Seth's brother. I have a PhD in mechanical engineering from Columbia. We have different approaches to the problems, although here, yeah, we definitely have different approaches to this problem because Seth really got upset that this is a I don't want to use a word like that, but this is a really
Phony
messed up.
physics
This is a
problem.
really messed up physics question. So it's bothering Seth. You can see. Okay, so anyway, what do? We try to give or offer approaches and try to help you understand how to offer approaches on basically how to offer suggestions on how to approach doing SAT math questions. That's what we're here for, and we also advocate going to Khan Academy because they offer hundreds of practice questions sanctioned by the SAT people, so you can learn what's on the test and then practice on Khan using their digital SAT course, and then go to College Board and practice on their practice tests. I think that's it. So please give us comments, dislike us. We comments are great. We get feedback. And if you have any SAT math questions, please email them to us at satmathquestionoftheday@gmail.com. Okay, everyone, have a great day. Bye-bye.
Bye-bye.